This is 2026 USA Junior Mathematics Olympiad problem number 4. It is an easy geometry problem, can be solved by angle chasing. Let O be the circumcenter of triangle ABC. Lines OA and BC meet at the point D. The AX center E of triangle ABD is on the circumcircle of ABC. Prove that the AX center F of a triangle ACD is also on the circumcircle of triangle ABC. An X center is the intersection of angle bisectors of an interior angle and two exterior angles. There are a lot of angle bisectors, so naturally, this is a problem of angle chasing. Let AE be the angle bisector of BAD and BE the bisector of the exterior angle at point B. For simplicity, we set the measure of angle BAE and EAD as alpha. And the angle BAC has a measure beta. So the exterior angle at B has a measure 180 degree minus beta, and the angle DBE is one half of it. It has a measure of 90 degree minus one half of beta. This angle. We are going to find another way to calculate the measure of angle DBE. Point O is the center of the circumcircle. Extend AO all the way to the other side of the circle to form a diameter, AK. Connecting BK, then the angle ABK here is a right angle. One part of the angle has measured beta, then the other part, ABK, has measured 90 degree minus beta. Moreover, by intersecting chord theorem, angle EBK and angle EAK, they share the same chord EK and they are congruent, both have measure alpha. Indeed, we find another way to calculate the measure of angle DBE. It is 90 degree minus beta plus alpha. Compare the calculations and simplify, we got beta equals 2 alpha. Beta equals alpha plus alpha. That means triangle DAB is an isosceles triangle. ABK is a right triangle, and we know DAB is an isosceles triangle with DA equals DB. It can be easily proved that the angles DBK and DKB are congruent with measure 90 degree minus beta. Therefore, triangle DBK is also isosceles with DB equals DK. That means DA, DB, and DK are all congruent. In other words, D is the midpoint of AK. However, AK is a diameter of the circumcircle and O is its center. So, D and O must be the same point. As a result, BC is also a diameter of the circle. We have two diameters here, AK and BC. The remaining part of the proof is straightforward. Let's see how do we find the eccenter of triangle ADC. Let's remove the circle and start to construct. First, F is on the bisector of the exterior angle at D. It intersects the circle at a point here, and we need to prove this point is the desired eccenter. Now look, O is the center of the circumcircle, so KOC is a sector. The angle bisector of KOC partitions the sector into two congruent parts. So the intersection is actually the midpoint of arc KC. As a result, if we connect this point to A, it must be the angle bisector of CAK. And the proof is done. Thank you for watching.